Welcome, everybody. Welcome to Basecamp X session 4. In this session, we will look at Starknet and especially how to build smart contracts. So without further ado, this is where you are. You're on the fourth session of the Basecamp. And then next week, it's the final session, which we will cover front end. So far, we covered fundamentals, where we learned about Cairo and Starknet. Then we took a deep dive into Starknet. We learned about different type of transactions. We looked at a node and so on. Then on the third session, it was a practical session. We looked at vanilla Cairo. We did Stark links, and now we're doing Starknet. We're building a smart contract, a simple smart contract. Now, for session topics. So initially, we'll install dependencies. I'll install the dependencies on a Ubuntu machine, but that should be similar to Mac OS as well. And for those who are using Windows, it's a little bit different, but let me know. Then we'll take a look at Hello World or Hello Cairo, and then we'll get into the counter workshop, and we'll learn the basics of a smart contract. And finally, I'll leave you with some resources. We'll play it by the year to see how this goes. And basically, the whole aim of this workshop is to reach a certain stage of the workshop and deploy the smart contract on Cipollio. Without further ado, we have the dependencies. So just to mention a little bit, initially, what's the most important thing here is to install ASDF first. So ASDF, you can think of it as a library manager where you can install different libraries such as Scarb, Starknet Foundry, or even Rust or anything else besides or outside of Starknet. It's a quite efficient and useful library manager that allows you to switch between versions seamlessly. We'll see that in a second. After we installed ASDF, we will proceed installing Scarb with the ASDF and Starknet Foundry with ASDF. So Scarb, it's a package manager for Starknet or for Cairo that helps you to install dependencies. You have the compiler and the language server, everything that you need. It's similar to Cargo for those who are coming from a Rust background. Starknet Foundry, on the other hand, is similar to the Ethereum Foundry that you have. It's a tool for testing tool, but they also have included a CLI. It's called SNCast, which allows you to deploy and declare your contracts on Starknet. Finally, there's the extension on Visual Code. It's basically the language server that helps you to give you more information about your code. I'm gonna switch to my virtual machine. So for this, I have from scratch a new virtual machine, and it's Ubuntu. And then here, I'm just gonna go into the terminal. So there's a question, I'm on Windows. Will this affect what's happening right now? So Windows is a little bit different because you have to use the WS2, I think, and then you have to allow Ubuntu commands to be accepted. It's a bit more not complicated, but you just have to allow installation with Ubuntu commands. Okay, so without further ado, as I mentioned, this is the terminal. So just to check if I have everything from clean, let me make this actually bigger. So I'll put ASDF and you'll see that command not found, Scarb version, command not found, and then SNForge version, again, command not found. That means I don't have anything installed yet. So to fix that, we'll go step by step and install all of these things. So you have this ASDF. It's already linked in the slides. So if you click on the ASDF, you'll have this. And initially, what you have to install first is, let's see. So we have a Linux machine, and depending on what type of machine. So if you have a Mac OS, you can install it with Homebrew. If you have a Linux machine, you can install with this. So I'll use apt install curl git because we need to install git first. I'll just copy the command here. So apt install curl git. So I need permission. So for that, I'll say sudo, and then I'll add my password. Sudo apt install git. Let's say it like this. You must manually configure to correct the problem. Okay, so this is something new. Let's see what's this. Maybe there's a new installation on my machine, which I had to do this configuration, but you should just install directly apt install curl git, and that should work. Let me see if this actually finished. It's actually a new error. That's the joy of workshops. Whenever you're doing live coding sessions, you never know what type of issues or bugs may come. So let's try that again. So apt install git. Finally, it works. And then if I type git, I should have this. So far, so good. Everybody's following. Okay, I'll take that as a yes. Okay, we have a yes. Now I have git installed. The next thing I have to do is clone this repo. So I'll just, copy this, paste it into my terminal, and I have that done. And then for the next step, I just have to install ASDF. So I've, depending on how you installed it, so I have bash and git, but you can do with bash and homebrew or bash and homebrew for macOS, depending on which installation steps you took. So for me, what I'll need to do is basically just add these dependencies in my bash RC configuration file. And then if you're using a Mac OS, you'll have to add this in your, which one? Let me see. So you can add this into your SHRC, or depending on the way you installed it, you'll have to add it. So I'll show that in a second for Mac OS, but just give me 1 second. So going back, I'll have to navigate to my configuration file. So to do that, I'm just gonna quickly clear this, and I'll say nano. Nusirat, if you can ask your questions in the QA, that will be perfect. And then I'll say bash RC. So nano is like the editing software. You can use whatever editing you have. For me, I'll use nano because that's something that comes in pre-installed with this new VM. And then here, this is the configuration file. You don't have to worry about all of these details here. What you need to do here at the end is just add this. This is something that I already added, so this is a comment. But what you have to do is just add this part. So I'll copy this. I'll go into my configuration file. I'll paste this in, and you have to save it, right? So I saved it. You can also add for completion if you're interested to add completion to your ASDF. I've done that. I saved my file. I have added this configuration. I'm gonna exit my configuration file, and now you can either restart your terminal or just say bash RC, and then this will basically load the new version of my configuration. And now to actually check if you have ASDF, you simply type ASDF. And then now this thing should pop up, like all the commands that you have available. And then I assure you, this is the hardest part of the installation. That's all you need to do. From here, it's just straightforward, simple. Let's see if we have any questions. No. Maybe just let me quickly show you on the Mac OS. So on the Mac OS, you also have, so you can use, I don't know, like, do we have nano here? We have nano. Okay, so you can say nano, and then here you can say RC. So this is my configuration. And then here you can add the ASDF as well, right? So this is the same thing that we did previously. Hope that makes sense. Now, for the next part, we'll have Scarb. So for Scarb, we'll have to install with the ASDF plugin. So you just navigate to the link that I've added in the slides, and then here you have ASDF plugin at Scarb. And then this will clone the repo for you. And then the next step, basically what you have to do is install Scarb latest, or in this case, we specifically will work on a certain version. So the version that we have is 2.8.0. So to do that, ASDF install Scarb, and then 2.8.0. Also, David was mentioning Docker. That's probably something that I should have specified initially. So for those who have Docker installed, there's also, or work with Docker, there's also an option to use Docker. And then if you use that, you won't have to install all of this by hand. So it will automatically be installed. But, I'll cover that in a second as well. Okay. We have ASDF installed Scarb. So now what we need to do is just preset our version for Scarb like this. And then if I say Scarb version, I should already be on 2.8.0, right? And then if you want to switch versions, so that's why it's so powerful to have ASDF. You can say ASDF install scarb latest, for example. You don't have to do this step just to showcase ASDF. You install the latest version, just give it a second. And now what I can say, ASDF global scarb, and I say, let me put the latest version predefined. So now if I do a scarb version, I'll be on the latest version. So it's very easy to switch between versions with the ASDF. So I'm going to switch back to the original version that we're working on, 2.8.0. Okay, that's it. Let's go to everybody following so far. If I already have Dojo Engine installed, will I be able to have multiple versions of Scarb? So Dojo Engine and Scarb are independent of each other. So you'll be able to install it. If you're using ASDF, you can have as many versions you want, and you can switch between those versions. Okay. Let me switch to installing Starknet Foundry. So this is another step that we have to install. So I'll grab this link, ASDF plugin add Starknet Foundry. I'm just gonna plug this in. We do the same things as we did with SCAR. So ASDF install Starknet Foundry. And the version that we will work on will depend on the workshop. So for the workshop, we have the 0.27.0. This is the version that we're working on. How do I know this? So if you'll go to the workshop here, you have like the setup. So we have install ASDF, the version for Scarb, and the version for Foundry. And then this is the step we're in. And then this is the last step that we'll need to do in just a second. And then here's the option with Docker. Okay, I've installed Starknet Foundry, and now I need to set my Starknet Foundry version. So ASDF global Starknet Foundry 0.27.0. And now Starknet Foundry by default comes with two programs or libraries. It's SNForge and SNCast. Both of them should be on the same version. So if I do SNForge version, you should be able to see that you're on 27th. Apologize. And then SNCast version, the same thing, 27. And that's about it, what we have to install. The last thing that you have to install is an IDE. So in this case, for us, we'll use VS Code. So depending on what type of machine you have to install VS Code. I already had this installed. I hope you already have some IDE installed, like a VS Code. So let me just quickly install this as well. Let me see if there are any questions. So for Windows, probably it's best to use the Docker image. So you'll be able to run that. Ikechu, please use the Notion page and then submit that Discord user to that form. There's a form inside that you can use for that. Okay, I have my code installed, so just let me restart my terminal to see if this is installed. I see code dot, and I should have it installed. Okay. Let me go into my desktop, and here what we'll create the hello world program. So we'll create a directory. So mk there, let's say workshop in this case, and then we'll cd into that. And then with Scarb, you can initialize a new project with Scarb in it, and that's about it. And then here you can choose which one you want to set up with Starknet Foundry or Cairo test. In this example, we're going to use Cairo test. Okay. Now we initialize the folder or the project with Scarb, and then we can open this to see exactly what we created. So this is your VS Code. Inside here, we see a source folder. We see a git ignore and a Scarb TOML. But before going into those, I said we need to install a language server. So go to the extension, Cairo 1, and this is the language support that you have to install, okay? Cannot be run. Kandish, can you run Scarb version by any chance? like this, and make sure you're on 2.8.0 SS. Okay, so we installed the language support. Now we can go back to actually, let me make this bigger a bit, like this. So we have the scarp toml. Toml is basically your configuration file for your project. And here you have the name of the package, the version, and the edition. We'll talk about the edition in just a bit. And then here you have the dependencies. So currently it's just bare bone, but with the counter workshop, we'll work on this. Next up, you have the git ignore. You have target here. Target is a folder where whenever you build your project, Scarp will build in that folder. And currently it's added as ignored in the git ignore file. And finally, you have a Cairo, lib.cairo. It's basically a simple code template. And here you have a Fibonacci sequence, and then you can see that you have a main function. And then this main function calls the fib function, and the input number is 16. So we'll get the Fibonacci of the 16th. And then this is basically just a pure example, right? And then here you have just a simple test that checks if the Fibonacci of 16 is actually 987. But that's basically like the hello world of Cairo. Initially, the Docker app. And once that's installed, you'll have to install the dev containers extension for VS Code. So for that, let me see. Actually, there's a question. ASDF installs Scarp 2.8.0 says, but doing... Okay, so Abdul, you forgot to set the globe. So if I go back to my machine, you say ASDF global Scarp 2.8.0, and then that should fix it. Let me know if that worked. Okay, now this is all I wanted to show installing the dependencies with the new virtual machine. It should be relatively simple on the Mac as well. With Windows, as David suggested, please use the Docker. But without further ado, let's actually get into the workshop. So let me just exit this, and then I'll go back to my slides. And then here, just to quickly iterate to what we prepared for you today, is the counter workshop. And then here, just to tell you a little bit about the counter workshop, it's kind of like an automated step-by-step workshop that helps you to create your first smart contract and deploy it on Starknet. And basically your objective is to go to the counter workshop, clone the repository, and then follow step-by-step the instructions and solve them. So that's basically it. And whatever we don't manage to solve in today's session, it will be as homework for you to complete. And then you'll be able to add or submit your finished counter workshop in this form. And if the homework is correct, you'll get an additional 10 points to your graduation. Does that make sense? ASDF is not available in the Docker. So ASDF is not necessary in the Docker. In the Docker, you already have the, what you actually need is Scarp and Starknet Foundry. That's what you need. So this is the counter workshop. So if everybody goes on this page, you'll have the counter workshop, and then this is basically what you have to do is clone the repo. So let's do that initially. So I'll grab this HTTPS. Now I'm gonna switch to my macOS terminal, which I'm more used to. I'm gonna increase my terminal font, and then CD desktop, and then here I'm gonna say MCAD. I'm gonna create a new folder, call it Basecamp X, and then I'll go into this folder. Now I'm gonna clone the counter workshop. So I'll grab this, clone, git clone, and then finally I'm gonna go into the folder, and then I just open the VS Code terminal, or the ID that we installed. This is what we have, but let's go back to the README file and then read step by step what we have here. This is the setup that we did. So what we did is install the dependencies without Docker, but there's also the option is with Docker. And then what you have to do is just have the Docker app, the dev containers extension, and then you can launch the Dockerize container from here. But that's basically it. Okay. So there's still some installations going, so I'll just give a couple of more seconds and then we'll go into the step one. And if there's still some issues, I can help during the break. The next step is clone the counter repo, and then we'll go to the step one. That's basically what we're doing now. So we installed everything. We installed the SCARB, we have Starknet Foundry, we have the Cairo 1 extension for VS Code, and now we're preparing to go to step one. Okay, so let's do that. So first, what we have to do is switch to step one branch. So I'll grab this link. I'm going to paste it in my terminal. And now I switch to step. You can also check your VS Code. And then this is the dev container that you can open in case you have Docker installed. But moving back to step one, let's see actually what we have as a goal. So first, initialize the project structure with the clone repository by using SCARB package manager and enable compilation of the Starknet contracts. What so the requirements here is basically when you initialize the project with SCARB, you have to name the package as workshop, and then you create a new Cairo file under the source directory named counter Cairo and add the following starting code. Finally, in the lib.cairo, you have to remove the boiler template or the code that the Fibonacci is already by default, and you remove that and just you have to add the counter module there. As verification, you do SCARB build. Going back to the requirements, so first what we have to do is initialize the project structure within the clone repository, right? And we use SCARB for this. In case you have issues, you also have the hint section. So here you can have more details about what you need to do. And you can notice that you can use the SCARB init command, but also additionally, you can pass an argument /name, and then you can add your package name. So in this case, what we need to do is we need to call the package name as workshop. So we'll go ahead and do that, right? So we'll say SCARB init /name. And then what we need to do is say workshop. And now what we say is that which test runner do you want to set up? You can choose Cairo test for our example. And then our package has been created. It's just going to say a warning file because there's already git ignored. This is because we need the git ignore for a workshop, but you can be sure that the target is already there. Now, to actually see for ourselves, I'm going to say code dot, and this is going to open my folder or my project. And then here I can notice that I have this SCARB TOML, the source, and then the git ignore. The git ignore should already have the target, but this is you shouldn't be concerned about the git ignore file. Now, let's look at our lib.cairo. This is the boilerplate code that we have, the Fibonacci sequence. And then we have the SCARB TOML, which is the default settings that SCARB will define for itself. So going back to the step one, let's see actually what we need to do. So we initialized the project with SCARB and we named it as workshop. You can verify this here. So you can see the package name is workshop. Then we have to create a new Cairo file under the source directory named counter Cairo and add the following starting code. So I'll grab this code. I'll go back to my IDE, and here I'm gonna just create a new file. I'm gonna name it counter.cairo, and then I'm gonna pass the code. Now going back to the requirements, we can see that finally what we need to do is to change the lib.cairo. We remove the code, and then we define the counter module. That's what we need to do. So we go back to lib.cairo. We select all of this, we remove it, and then what we do here is basically import our counter file like this. So you say module, mod for short for module, counter. And then this will automatically pick this file. Okay, so far so good. Finally, for verification, we do a scarp build. So if actually we're not done yet, right? So what we need to do is actually, let's see. And then this is the last step. So we have to enable compilation of the Starknet's contracts, right? So that's one thing that I forgot to mention. So to actually enable compilation for Starknet's contracts, what we have to do is basically change our scarp TOML configuration. And if you go to the hint section, you'll see some of the information here to help you get started. So this is if you want to read more about what's happening, but basically this is a way to tell to Scarp that we'll be compiling Starknet contract. So to do this, you need this part and then this part, right? So I'll go back to my Scarp TOML. In the dependencies, I'll say the Starknet version that or the Cairo version that I'll be using. So it's 2.8.0. Any version bigger than 2.8.0 works. And then finally, to actually target Starknet contracts like this and without less. And then you'll see Scarp is resolving some things, and that means that it got the new configuration, and now you'll be able to compile Starknet contracts. So let's go back to our step one. Finally, you can, so basically we clone the repository, we initialize the Scarp, the project, and then we enable compilation of Starknet contracts. That's what we did. So we can try and test with Scarp build. So I'll go back to my terminal, say Scarp build. In this case, my project is compiling, and if you have a successful compilation, that means that you've successfully passed the first. Okay, how's everyone doing? Are we good to go for step two? Pass the dependencies on the chat. Okay, I can do that. So it's not ideal, but I can do that. No, you can always check this. So basically, you have everything that you need. This is the how we actually target the Starknet contracts, and yeah. Okie dokie. Let's move to step two. So we successfully finished step one, and now we're going to step. I'm gonna grab this git checkout step two. I'm going to my terminal, pass this command here, and I switch my branches. You have to, so if you're installed with ASDF, you'll have to set ASDF global Starknet Forge 0.27.0. That's what you have to do. But basically, you have to set up your Starknet Foundry. So is there a critical difference if you choose Starknet Foundry instead of Cairo test when running Scarp init? So so if you're choosing Starknet Foundry, you will basically create your project with Starknet Foundry, like all the settings with for Foundry. But the reason why I chose Cairo test is basically to go step by step and show you how to set up your project with all of this. But initially, like if you start building application, you should go straight forward with Starknet. As I know, some like currently the 0.13.0, so the Starknet Foundry version, has some issues creating the basic template. So yeah, just follow my steps here, and then you'll be good to go. Okay, let's move to step two. Let's see what we actually have to do. And this is the part we add Starknet Foundry dependencies, or Stark SN Forge in this case. So the goal is to add SN Forge as a dependency with your Scarp TOML file to allow execution of tests with Starknet Foundry. Starknet Foundry is a cool tool. You can check their documentation. They have all sorts of nice features, cheat codes, and then you can use it during your testing suite, and you can really build like a complex unit tests, E2E tests, end-to-end tests, and so on. Okay, so as a requirements, what we have to do is in your Scarp TOML, you have to declare SNForge SED package as your project dependency, and then you have to enable Chasm contract class generation. So enabling Chasm, this is the thing that we discussed, I think, 2 sessions ago. We'll need this for our deployment script. And then the next one is we have to define a script named test. And then finally, we need to set up the addition. But let's do this step by step. So Go to hints, and then here you'll find the useful documentation. So let me see the Starknet Foundry hints. And then here you should have like all of these useful links. You don't have to type it by hand. So you can grab this link, or like you can copy this, and you go to your VS Code. And then here under the dev dependencies, I'm gonna add SNForge. Okay, so we have SNForge, you have Git, this is the repository for Starknet Foundry, and this is where you save the version of Starknet Foundry. Next up, what we have to do is, so we have to enable Chasm contract class generation. To do that, you can come here down and say Chasm equals to true. This is something that you need for the deployment script. It's not necessary until you reach step 15 to actually deploy your script. And we are done with the first requirement. Now for the second requirement, we have to define a script named test to be able to run SNForge test. This is not a mandatory step, so to say, but it's a good way to predefine a lot of commands and make them accessible with Scarp. So I'll actually do that initially. You can also go to this link. So in the hint section, there's Scarp running scripts, and here you have all the explanation about how running scripts can be helpful. But basically, what you have to do is you have to define a script in your Scarp TOML, and there you can define, like for example, foo, and then this is a certain script that will run. And the next time when you can run scarp foo, it will run this command. So it's pretty neat and useful. So to do that, I'll say it here. Is it scripts? Scripts plural. And then I'll say test, because whenever I'll run scarp test, it will trigger this command. So it will trigger SNForge test, right? This is what we have to do. And then finally, for the last step, let me close these links. So the last step is basically we have to set our edition to 2023-01. And the reason why is that, so this is the kind of like, you can imagine that your project uses a certain prelude version. And currently the latest one is 2024-07. So this is July, this version. And you can find out more information about this. But this is basically like the core library packages that your project uses. And then this is the latest one is, I think, this one. But the 2023 version uses all of the libraries. So in case in the future, if you want to build more efficient projects, you can use the latest version. And then you'll have to import, the libraries that you're using one by one. If you're using the 2023, we'll use all of them. We'll name this. And then I think that's about it. So we just run Scarp test in this case. And let's see if this actually compiles. And then we have a test. And now you can notice that we actually have a test that is passed. So this is test SNForge. What is the SNForge dependency? This is the SNForge dependent. We add the version for Starknet Forge. This is the way we tell to our compiler and to Scarp that we're using Starknet Forge. And this is the repo of Starknet Forge and the version that we currently use for our workshop. You can simply grab the link, I guess, from here. So if you go to the Starknet Foundry documentation, you can grab this link if it's too much to type. Okay, finally, what I want to show you. So now we use Scarp test, but this is because we already defined the test script, right? So this is super useful for us because otherwise we will have to always say SNForge test or whatever command you're using. So these commands are pretty much the same, right? We just defined Scarp test. Whenever a test is invoked, this command will launch. So this is quite useful. And here you can predefine a lot of different scripts for you to run only from Scarp. Yes, I can let the Scarp TOML for just a few. If you already finished, you can go to the next step, and I'll give you also 2 minutes to. I'll go through the requirements, and I'll give you 2 minutes to solve the next step, and then we'll solve it together. So first, initially what you have to do is switch the branch to step 3. And then the goal here is to basically implement your constructor function to initialize an input number and store a variable named counter within the contract. The requirements are: store a variable named counter as U32 type in the storage struct, implement the constructor function that initializes the counter variable with the given input value. The input variable of the constructor function should be named initial value. So these are the requirements that are needed. And then for the verification, if you completed everything and successfully, the SCARP test should pass all the tests. You have some hints here, and I'm going to give you 2 minutes to work the exercise. The question is, what should be in the libcairo? The libcairo should be your module counter, the file that you're working with. So we our lib, you can imagine as the parent file that imports all the modules that you're working with. So we have the counter Cairo file, and we'll import that file specifically, the module. And then this is the name of the module that we work here. Prem, I would suggest to follow along just to see what we're doing, and then you can rewatch the videos after. Silvan, we can debug together. Nusirat, if you have issues with the first tab, you can actually check the hints, and then you'll be able to work it out. You have to initialize the project with a certain package name, and then you have to enable Starknet contract compilation, and then you have to create a file named counter Cairo, and then change the lib Cairo. But everything is explained here, so you can check that out. Okay, 2 minutes passed. We can check step 3. So let's speed run through this, and after that we can take a small break. So let me switch my branch. So let's see what we need to do. So we have to create a constructor function that initializes an input number and store a variable named counter in the contract. Let's go back to our counter. So initially here in the struct storage, we have to store a variable named counter, and then the type of the data type of the counter should be U32 because that's what the workshop requires. Counter as U32 in the storage struct. So we have this. Let me make this a little bit bigger. So this is the first step. Then the second step is implement the constructor function that initializes the counter variable with the given input value. So constructor functions, if you're coming from a Solidity background, constructor functions are basically the first function that will run when you deploy the contract, and it will only run once, and that's it. So to actually create a constructor function, we have this attribute named construct. And then if you install like the Cairo 1 extension, you should have some information about this, how it should look like. And then you can also hit tab and it will autocomplete. So let me see, find constructor. And then here we say ref self contract state because we're accessing the contract state of our contract. And then inside here, you can do like initialization, the variables of your storage and whatever you need. But in our case, what we need to do is basically give an input value, and this input value should be initial value. So initial value. And then with this initial value, what you need to do is basically initialize the counter variable, right? And because our counter variable is U32, the initial value should be as well U32. Now, to actually initialize the variable counter in our storage, you can call self, and this will give you access to the contract state. And here you can say self counter, and to actually modify the value of the counter, there's this function write that allows you to do that. And then inside write, you add your initial value, and then this will update the counter variable. There's another function read that we'll get into in the next step as well. Okay, this is some error for my language server, but that should be fine. Sometimes it complains. Now, if I did everything correct, I should be able to run scarp test, and then I should be able to pass the test that we have attributed for this step. Let's see. And we successfully passed the test, right? So we have check store counter. And if you're interested like what these tests are doing, you can also check them out. It's not necessary, but to give you like an idea, you can go into the test, and then this is the test step. We can see that basically we initialize a variable with 12, the initial counter with 12. We deploy our contract, and then we check if this is actually stored or not. But this is basically, it's not necessary to check this the test if you're only interested. Okay, you successfully finished the first 3 steps of the workshop. There's a question. Starknet also encourage us to contribute to project as OnlyDust. Does it also benefit students somehow? Sure. So OnlyDust is a platform that it's an open source platform for contributors. You can join a certain project and then contribute to the project. And it's also a way for you to also get rewarded for your work done. So for example, if you do a PRs and help projects to with your contributions, you get paid for your contributions. And there's actually a lot of developers that are using this platform, and you can check it out. But it's an open source platform, encourages developers to contribute to open source. It's a great way to test your coding skills and improve your coding skills. And you also get rewarded for your contributions and paid for your contributions. Okay, there's a question from Zachary. I'm getting right not found. Self counter. Make sure to change your Scarp tunnel. Make sure to check if your edition is set to 2023-01. Okay, I think that should be fixed. That should fix it. Okay, so now let's go to step 4. And again, we'll do step 4, step 5, and step 6, and then we'll deploy the contract, and we'll analyze what's left. And you'll see that every step will gradually increase a little bit in difficulty, but also teaches you new concepts. So that's the aim of the workshop. Start easy, initialize the project, create your first variable in the storage, and then move gradually to more advanced parts. So let's see. Step 4, you have to implement an interface for the contract with which contains the get counter function. This function should return the value of the stored counter variable within the contract. So interfaces are basically public functions that allows the block explorer and other smart contracts and users to interact with your smart contract. And to actually implement this, you have to follow the requirements. So what you have to do is implement an interface for a function named get counter. So this is the function that you have to create within the interface. And you have to return the counter variable. So we'll have to read the counter, and then we'll return this. The get counter function must be within the contract's interface named iCounter. So whenever you define the interface, you'll define it as iCounter. To pass the verification, you type scarp test. And if you want more hints about how to create interface, you can check the hints section and also the links attributed here. So let me read this again and see what we need to do. So we'll implement an interface for the contract, which contains the get counter function, right? If you go to the hints, you'll see that to create an interface, you have to define a trait named iCounter, because if you name it differently, the test will fail. And you have to mark it with the trait with this attribute, Starknet interface. That's how we define these interface with Starknet. If you want to read more about it, you can check chapter 13. You'll have here the interface, how like the contracts blueprint, and the interface are basically like the inputs and the outputs or the contract signatures methods. Okay, let's switch to our VS Code. We go to the counter, and then usually interfaces are at the top of the file. So here we're gonna say Starknet interface. And then if I go back, we'll see that I'll have to name this as I counter. So you can also say pub trait I counter. And then usually for I counter, we have to define a placeholder. This placeholder can be of any variable, but in this case, we'll call it T. You can name it T contract state, T, whatever you want to. So it's just basically a placeholder that will pass the state of the contract. And then we open the curly brackets. And then here, what we need to do, if we go back to our exercise, we'll have to define the get counter function. So fn get counter, and then here for the interface, we only define the inputs and the outputs. We don't define the actual code logic. The code logic will happen inside your Starknet contract here exactly. So what we need to do is we read the placeholder or like the state of the contract, right? And I said read because we don't change it. So to actually read the state, there's actually a symbol, which is at, and then so you can say self, and then you pass this at symbol and T. And what does this mean is that this basically at symbol is a snapshot. A snapshot means that it's a like a copy of that contract state at that certain time and place. So it's only a copy. Because it's a copy, you cannot modify this copy. And then finally, what we need to do is actually return the value. And then the return value will be the counter variable. And the data type of the counter variable is U32. And that's what we'll return. If you want to learn more about the snapshots, it's useful to use the Cairo book. So you can say snapshots here, and then you can check what are these snapshots. And then you can see that basically like you have a description here, and then this is the snapshot. So it acts as a copy of that certain variable that you pass, right? So you can learn more about this here. Okay, now let's see what we need to do. And now what we need to do is finally is actually implement the code logic for the interface. So to implement the code logic for the interface, we'll go here inside our contract. And now, like, if you remember, I think in the first session, we showed like an example of how like a smart contract looks, and there was an implementation block, right? So the implementation block, you can call impl, and then you name the implementation block. So for us, we'll say counter impl, and then we have to press say or state the interface that we're using. So off, and then we'll be using the I counter that we created here. So to use that, I can say I counter, and then inside here, I'm gonna pass the actual contract state, and then I'm going to open the curly brackets, and then I'm going to quickly check what's happening. So it says trait not found, right? Which means that I cannot actually access the I counter because I cannot see it. So how I can see it, there's two ways to actually do this. It's either use super here, which basically allows me to access the what's everything outside of this scope. So like if I use super, I can access everything outside of the scope. Or another way to use to actually do this is you can import it by using use workshop counter and then I counter. And then this is another way to import this interface specifically. Both ways work, and both ways are correct. Now, if I check here, it says you can go to the highlighted part, and it says not all trade items are implemented. So it says that it's missing get counter, and this is because we haven't implemented this code logic yet. So let's do that first. So we say fn get counter, and then again we're gonna say self. And then because this function is a read function, it only reads our contract state. I'm gonna pass a snapshot on contract state, and then finally I'll have to define the return. So the way we return the variable, and then here what I'll need to do now is actually I'll need to read the counter variable and return this. To do this, there's actually two ways to do it. it's either you say let value equal to, and now we access our self, and then inside self we should have access to counter dot read like this. And then finally what we can say is return value. So that's a way we can actually do it. Now, as I mentioned, these are two different functions that you can have, like the read and write. The read will only read the value of the variable in your storage, and the write will actually change the variable in your storage. Because we have here a snapshot, we can only use the read function. Even if I'm trying to use the write function here, because I passed the snapshot, the compiler will complain and it won't allow me to compile my contract because it violates the rules of the function. So this is one way to actually return the value that we have stored in the counter. But let me show you there's another way to actually do it. So you might encounter this in other smart contracts. So to do it, you can actually delete this whole line, and then you can just call self counter read, and that's it. So it's pretty much simple. And now you ask, like, how is that even possible? So the reasoning behind it is that if I don't have these semicolons, if I don't add these semicolons at the end, then it automatically will return the value here. This is similar to the Rust as well, if you're coming from a Rust background. So these are the two ways you can actually return the value. So this is quite simple and straightforward. If you're working with more complex projects and more, if statements and things like this, probably using return and then the value would be more appropriate. Okay, and then for the last thing that we have to do is because we created an implementation block and we implemented the interface, we also have to expose this implementation block. We need to expose this to the block explorers, to the smart contracts and the users. And to expose this function, we have this attribute called ABI. And then here we have the embed v0. So this is the attribute that you have to use to actually expose this code logic for the implementation block. The ABI is similar to the Solidity part, and then the embed v0. This is something has to do with future compilers to be backwards compatible. So that's why we have to use it. Okay, I save this. I'll go back to my exercise to see if I implemented everything. So we implemented the get counter with the interface. And now finally, we just need to run this test first. So let's do that. Let me go to my terminal, spark test, and let's see if we pass the test. Let's see if there's any question. No questions so far. Okay, and we can see that we managed to pass the test, check stored counter. And then we can see also like the gas usage. We used the 165 gas so far. Yeah, so the API is required, so it's public. Does it pass for you? If you don't have that, let me check actually. Let's see if this actually works. Yeah, it passed. Interesting. So basically, I know exactly why, but because it's like my tests have direct access to these contracts, but in order for your contracts to be exposed, your functions to be exposed to the public, you'll have to expose this like that. This is just exposing these functions publicly. But you can read more about this here. So we have here, and we should have public functions somewhere here, right? So this is the ABI, and then you can read more about it. Okay, now let's move to the next step. We we still have like 35 minutes, so let's try to finish step 6 as well. I'm gonna give you 2 minutes to solve step 5. What you have to do is to implement another function in your interface called increase counter. And then this time, this function will be a write function. So you'll have to be able to modify the state of the contract. And the code logic that this function will implement is basically you're going to increment the value of the counter variable in your storage. That's what you have to do. I'm going to give you 2 minutes to complete this exercise, and then we'll solve it together. Okay, time is up. Hopefully you managed to solve the exercise. Otherwise, you can do this together. So I'm going to switch my branches. Now I'm in step 5. And then here, as I mentioned, we have to create another function in our interface. And this function will be able to modify our contract state. And now what we need to do with this function is basically just increment the counter value by 1. So let me first create the function. So in the interface, so fn increase counter, and then this doesn't return me anything. So it just increments the value, doesn't return anything. Now to actually be able to mutate or modify the contract state, you will have to pass a certain keyword. And if you did your Starknet exercise, you probably are familiar with this keyword. It's called not mute, it's called ref, because this passes a reference to the actual contract state. And then you're gonna say self and then t. And then this is how we actually will be able to modify the state of the contract, because we're actually passing the reference where that contract state is. Now, automatically, like the implementation block will be complaining because we're missing the increase counter function. So let me just quickly fix that. Fn increase counter, and then here we have ref. So we pass the reference of the contract state. And notice we don't have to pass the snapshot, because the snapshot, as you remember from the previous step, this acts as a copy. So, but here we don't have, we pass the reference. And then we open the curly brackets. And then here, what we have to do is to first read the counter value and then increase it by 1. So there are a couple of ways to do this, but let me show you. You can do it like the long way. So let the value be equal to, you can either say self counter read, or you can do this. That also works, or you can also call the self get counter. This also works. So there's multiple ways to do it. And then finally, what you can do is you can say self counter dot write, and we're going to invoke the write function because this allows us to actually modify the value of the counter. And then we're going to say value plus 1, right? And then I can say semicolons because I'm not returning anything. So this should also work. If you want to simplify it further, you can just say self counter here instead of value. And then if you're fan of one-liners, you can have a one-liner as well. All options should work. Now, let me actually test this out. So I'm going to run scarf test and let's see if this actually works. And it worked. Just for the sake of showing that all the options work, I'm going to run the other one as well. And then this also worked, right? So there's multiple options that you can solve this exercise. And that's it. This is step 5. Should be straightforward. Now, going to step 6, and this will be the final step that we'll actually solve in this session. And then we'll switch to step 15 to actually deploy the smart contract, and the rest of the workshop will be homework. So in step 6, we'll get familiarized with the events in Starknet. And the goal here is to implement an event named counter increase that emits the current value of the counter variable every time the value is increased. What you have to do is define a variant named counter increase in the event enum. So events will be enum type. Then inside this, you have to define, so basically you have to define a counter increase struct. And within this counter increase struct, you have to define a value. And then finally, what you have to do is emit that certain event inside the function, the increase counter function. You can check the hint to get started, and you can check also the resources that has been allocated here. So you have the contract events. To define events, you use the enum, and then the event name. Event is a special name that you have to use. And then inside here, you use, let's say for us, it will be counter increased. And then we'll have to create a struct named counter increase. And inside here, we'll pass the value and the data type for that value. Okay, note that you'll have to add some attributes here on the top, but we'll cover that. So I'm gonna give you 2 minutes and then we'll solve it together. Okay, time is up. Hopefully you managed to work it out, but if not, let's go. So to do this, I have to first define an enum called event. So let me do that just quickly here. And then basically you can say there's an attribute called event like this. And then you'll have like a small template on how this looks like. But basically what you have to say is event, and then finally you'll need to say derive, and then drop, and then Starknet event. So this is so just to explain this. This is how we mark the and tell the compiler that this section of the code will be an event section, and then we derive these two functions. The first one is drop, which basically allows us to destroy these resources after the end of the program, because by default, these resources won't be destroyed when it goes out of scope. And to actually be sound with the compilation, you'll have to implement this drop function. And then we implement the Starknet events function as well. Now, all is left to do is to create the enum and call event. And then inside here, we need to create the name counter increased. So counter increase, counter. And now you'll see that the language server complains because we created this, but we haven't implemented the struct yet. So to actually do that, you need the same thing. So you need a derive, and then we'll have to say drop and startnet event. And then inside here, we're gonna say struct counter increased. And then here we have to define actually I butchered the naming. And then here we have to define what we actually want to emit, right? So what type of value or what variables we want to emit. And in this case, I'll say value, and then this value will be a unsigned 32 type. That's what we want to emit. So that's how we implement. So to recap, events are marked with the event attribute. We derive the Starknet event functionality and the drop functionality to actually drop these or deconstruct or destroy these resources when the goes out of scope. Otherwise, they won't be destroyed, and then you're gonna have compilation issues. We use the enum event to define all of our events. And one of our events that we defined is counter increased. Now to define this counter increase, we have to create a struct. It has to follow the same derive for drop and startnet events. And then inside this struct, we define the values or the variables that we want to actually emit. That's all you have to do. Once that's done, one last thing that we have to do is basically to call the emit function, and we'll have to emit in the increase counter whenever we increase this counter. So how we do that, you can invoke self, and then here you have the emit function. And then inside here, we need to pass the name of the event. So this is counter increased. And then what we need to do is open curly brackets. And then now it will say that it's missing the member value. So we need to pass the member value. So for that, we're going to say self. We can actually read this directly from our storage, and then value like this. Let's see. So this should fix it. So self emit, and then inside here we pass the event that we created, and then we pass the we say value self counter read. Another trick that you can use here. So I had to state this value and then say which the actual value. But another trick that you can do is if you have something like this. So you have value, let value equal to, and then you can say counter dot read. Now I can pass it directly like this. And then Scarp or Cairo will automatically know that this is attributed to it. But this only works if the two naming are the same. How can I change my package name? Inside your Scarp TOML, you can change it here in the workshop. Okay, so I'm reverting back to the initial setting that I have like this. Just I wanted to showcase that. I have some language errors, but that's nothing we need to be aware of. Okay, last thing is to actually run Scarp test and to see if we manage to solve this step. So Scarp test. And then you can notice that test counter event has successfully run. Again, if you're interested in like what type of test is running, you can see here, this is the Starknet Foundry test. It's also a nice way to get started with Foundry and see what exactly happening. But this is like the cheat codes that are being used by Foundry and allows us to spy these events. Okay, now let me see, why we cannot use self-get counter. We cannot use self-get counter. I never tried that. Value equals to get counter. Let's see if this passes. It should work. It should work. It should work as well. I think both options work as well. That's actually a good point. Yeah, you can use self-get counter. So multiple ways of doing this. And then, yeah, thank you, Michael, for the tip. That's actually good. Okay, so now we finished step 6. Before actually moving to deploying the script, I would mainly want to go past quickly through these, the rest of the steps, so you're aware of what you're doing. So just to give you a recap, so step 7 will introduce an external contract called kill switch. So initially you'll have to add this to your Scarp TOML, similar as we did with the other dependencies that we use. And then what you have to add is some external additional settings in your Scarp TOML under this section. So build external contracts. Then step 8 will basically, you'll have to initialize the kill switch contract. You'll store the address of the kill switch in your storage. And then you'll initialize the constructor function with this input variable. And then finally, step 9 will be actually using that kill switch mechanism inside the increase counter. And you'll see if like the kill switch has a function that's called isActive, and that isActive will return a Boolean data type. So it's either true or false. And depending on the value that returns, you should create the if function in that way. No problem, man. We're not ready yet. We still need to deploy the the contract. So just to quickly recap. So step 10 will we'll have to use the protect. So in step 10, what we'll do is we'll use assertion. That's another way of actually reverting the transaction. So what we have here in the increase counter function, you'll use the assert method, and that will actually revert the transaction instead of passing as we did previously. And then that's something that you'll be experimenting. Like if I submit a transaction and reverts, that means that some of the logic inside the function you return because an assertion failed. So that's what you have to implement. And then step 11 will introduce Open Zeppelin. It's another external dependency that you have to add to your Scarp TOML. And here you'll add the ownable component. And components are a nice feature that acts as a blueprint for your contract. And then you can implement this blueprint several times across your project. But make sure to follow all these steps. And then if you have any questions regarding the homework, or you reach you have some issues, you can check the hints, or you can also write on Discord and we'll be able to help you out. Now, hopefully that makes sense. Now we're just switching to step 15 to deploy this smart contract. If you manage to finish all the first step 6, like first 6 steps, congratulations. Now we'll actually deploy this. So let's move to step 15. I'm just gonna switch my branches to step 15. And then you can read this information. So what you have to do here is to install first npm install. Zachary, you'll have to name the package workflow, but if you have any more issues, I'll be able to help on the Discord server. So let's install the dependencies. We're gonna call npm install. These are several. If you don't have npm, you'll have to install that. And then what you have to do here is basically, well, we already done this in I think 2 or 3 sessions ago. I assume you already have a wallet, but if you don't have a wallet, I have this Argent account. Let me actually create a wallet quickly. So I'm on Sepolia. You should be on Sepolia as well. Make sure to select the standard account. And then now I have my wallet. If you remember, I have to fund this wallet. And to fund this wallet, I have to go to Starknet faucet. And if I remember, I should have a faucet here. I pass this here. I complete the CAPTCHA to make sure I'm not a robot. A lot of CAPTCHAs, more CAPTCHAs. And make sure to select ETH as your funds, because the current deployment is focused on ETH. In the future, we'll support both for ETH and Stark, but that's how the script works currently. So we'll wait for a confirmation to actually receive these funds. I already have the ETH. And then the final step that you have to do is to actually deploy manually your account if you haven't deployed it yet. So make sure to deploy that. So you do it by going into your settings and then deploy. And then once that's done, we can go back to our counter workshop, and then we'll have to create here. So we did this step. We created a wallet, we funded the wallet and deployed it. Now we have to create an environmental file. So I'll go back to my project, and outside here, we're gonna call .env, and then inside here, we'll have to we'll add the private key to the environmental file. So let me grab this link here, or code. We have the deployer private key. So to obtain the private key, you go to your Argent account, go to the account that you created, and then you can export the private key. Also make sure this is just testnet. Make sure to not share the private key with anyone. This is just for the exercise. This is the private key. Now, finally, what we need to do is also export the public key of the wallet. So I'll grab this code. I'm gonna try to speed up a little bit so we manage to finish everything in time. So I need my public address of my wallet. So if I go back to my Argent account, this is your public address. You'll copy this and you'll add it here. And then as for final step, you have to use an RPC endpoint. And then the RPC endpoint that we'll use is the Starknet Sepolia Blast API. So you can copy this line here and add it here. That's all you need to do with the environmental file. And then if you have all of these 3, you should be good to go. Again, make sure to create a wallet, fund the wallet, deploy your wallet. And once it's deployed, you export a private key, the public key, and then you add the RPC. Now, to actually run the script, initially what you have to do is to go to the deploy TS. Because you did it halfway through the exercise where we kind of like have a checkpoint, we'll have to make some modification here. So I'll just quickly run you through these modifications. So we have here in the script, deploy TS. And the first modification that you have to do is the constructor function. This script currently works for the full exercise, but if you completed only the half of it, you'll have to comment these 2 variables out. So we have initial value, and that's all you have to do. And for the sake of this exercise, let's say the initial value of how many? We have 94 participants. We're going to say 94. I'm going to say how many participants we have. Okay. And then another thing that you have to take care of. So if you named the workshop differently, make sure that this naming is correct. So what you have to take care of is that whenever you go to the target and you look at the files that have been compiled, it should be the same name. So we have workshop counter contract. That's what we actually need. So if you named your workshop differently, make sure that these names are the same. Okay, so far so good. There's some errors, but I'll help you after I'll deploy the script. So last things that we need to do is basically just run npm run deploy. So to do that, let me go to the terminal, npm run deploy, and we can see if actually this works. So we connected with the account. You have the address and the private key here. And then if we wait a couple of seconds, it will automatically deploy the smart contract that we created. Okay, and this is the smart contract that we deployed. We copy this, and then we'll go for starkscan.co, for example. We'll switch to Sepolia. Make sure to choose the appropriate network. And then this is my contract that I passed. This is, you can see Cairo 2, 5th of September, 1753. So just 1 minute ago, if you can see here. And to actually see if this is the counter that we have, we go to the read write contract and we'll see a get counter. Now, if you remember, the input value that I put in the initial value is 94. So if I call this contract, the function now, it should return 94. And make sure to select decimal and you'll see 94 here. Now, if you want to modify this and increase it, you can actually connect your wallet. I'll connect my Argent, connect, increase counter, write, and then here I'll confirm the transaction. You can also open this link to see if actually has been finished. Now, okay, one thing that I forgot to mention, remember in session 2, we said that the new update will be deployed, the 13.2. Well, the update is already deployed and now everything is super fast on Starknet. You already see that it was already accepted on L2. So the confirmation was like 1 or 2 seconds. So everything is super fast now. If we go back to the get counter, you can see decimal 95. Now let's do another try to see how fast is this, just to prove my point. Right. Get counter, I open this transaction. It's already accepted on L2. I'll go back to my read, get counter, query, decimal 96. It's super fast, right? Yeah, this is 13.2. So congratulations for deploying half of your smart contract. Now, remember, you'll have to finish the rest of the contract until step 14, and then step 15, it will be the actual deployment. Now, to just going back to the original presentation, make sure to, once you finish your homework, to submit via this form, and then after we'll correct the homework, you'll receive 10 points to your graduation. As for resources, again, it's important to use Cairo book. Cairo book has everything that you need to know about Cairo in general. The Starknet book is the documentation about the Starknet, and then Starknet Foundry, if you're interested in creating tests, you can find more information about that there. Now, I included as an optional Starknet by example. Starknet by example is a collection of Starknet smart contracts that you can analyze at your own will to see how to build other more complex smart contracts. And we reached the end 3 minutes earlier before we actually actual time. So if there are any questions, we already have Michael deployed. Congratulations, Michael. Let me actually see your smart contract. Now you made me curious. Let's see if you're bluffing or not. Is it this one? No. Let's see, Michael. Maybe like this. Maybe it's not deployed yet. Maybe it takes a little bit of time. Or did you deploy it on mainnet yet? That's a good question. Anyway, good job. Oh, we have the Sepolia. Okay, let's see. There it is. Nice. Congratulations, Michael. And you have the 95, correct? Nice, Michael. Good job. And yeah, thank you everyone for joining this session. Enjoy the rest of the day.